Hello, my name is Niusha Hosseini Chime. I am an assistant professor at Virginia Tech. The title of my presentation is Modeling Adolescents and Young Adults Drinking and Driving Behaviors in the United States. This is a list of my wonderful collaborators from different institutions, and this project has been funded by the National Institute of Health, and the content is solely the responsibility of the authors. I would like to begin my talk with a real story. In 2018, in a car crash in Walnut Creek, California, 2 teens died and 3 were seriously injured. The driver was drunk. They got together for the last time before each joined a different college. Motor vehicle crashes are the leading cause of death among adolescents. 6 teenagers per day die due to motor vehicle crashes. The highest fraction of drivers with blood alcohol content of 0.08 or higher was for young adults aged 21 to 24 in 2017. Factors influencing driving while impaired, or DWI, have been studied extensively. For instance, we know some of the DWI policies are effective. Enactment of 9 laws of minimum legal drinking age is associated with 1,135 lives saved per year. Police enforcement is associated with reduction in DWI crash rate. Parental monitoring is another important factor. Past studies of longitudinal nationally representative data indicate that parental monitoring reduces DWI. Binge drinking is significantly associated with impaired driving, and it is prevalent. Among high school seniors, 27% report binge drinking over the last 30 days. Factors influencing teens drinking behaviors have been studied as well. Each additional dollar per capita spent on alcohol marketing is associated with 3% increase in alcohol consumption by individuals aged 15 to 26. And each additional hour of exposure in watching alcohol use in movies is associated with 15% increase in the probability of initiating alcohol use in the next year. So alcohol advertisement increases both initiation and consumption of alcohol. Peer have lots of influences. Exposure to alcohol-related information on social media increases both level of alcohol consumption and chance of drinking initiation. Past studies identified determinants of impaired driving using conventional statistical analysis. To the best of our knowledge, no study has explored complex interactions of these influences. So the main objective of this study is to identify, map, and simulate key mechanisms and feedback processes that affect alcohol-impaired driving among teens and young adults in the United States. We started this project by reviewing the literature and exploring multiple longitudinal data sets. Then we had our first group model building session. The products of these processes are shown in green boxes: reference mode, policies, causal loop diagram. Then we simulated the model and generated a subscripted model. So our model can generate behaviors for different age groups, 15 to 24. Then we calibrated the model using different data sources, and we generated results, and we are going to simulate the model with our participant in our second GMV session, and hopefully revise the model based on their feedback and come up with policies. This picture shows our first GMV session, and it was conducted in October 2019. It was a 2-day workshop, and this map shows what we generated at the end of the second day. Our participants were experts in the medical, epidemiology, public health, policy, traffic safety, youth behavior, and health statistic fields. Now I'm going to show you the causal loop diagram. You can see we have a stock of abstainers, teenagers who do not drink, non-DWI drinkers, teenagers who drink, but they do not drive after drinking. Alcohol impaired drivers, those young adults and teenagers who drive after drinking. Some of them get arrested and a fraction of them stop DWI after arrest. We call them never DWI again. Our feedback loop affects these rates. Drinkers becoming abstinent, abstinent becoming drinkers, and so on. So I'm going to show you the first balancing feedback loop in our model. Total DWI trips is the multiplication of average frequency of DWI and alcohol impaired drivers, number of drivers who drink and drive. Average frequency of DWI is the number of times a teen drive after drinking per year. And that gives us total DWI trips. As number of DWI trips goes up, arrest goes up, and some of the kids would stop DWI and move to this stop, so number of alcohol impaired drivers goes down. That is our first balancing loop. It's called enforcement. The second one is near crashes. As DWI trips increases, number of DWI trips increases, near crashes goes up, and fraction of DWI, stopping DWI increases, and they leave, more people leave this stock, so it leads to a lower number of alcohol impaired drivers. This is B2. B3 is about perception of enforcement. As DWI trips goes up, as alcohol impaired drivers goes up, DWI trips increases, which leads to higher arrest, higher visibility of enforcement, which lead to perception will get caught. People perceive that, the perception goes up, and that would lead to higher fraction of DWI stopping DWI and lower fraction of non-DWI drinkers becoming DWI. Finally, there are two other feedback loops here, balancing loops, which are related to DWI policy. As number of crash DWI trips increases, fatality goes up, pressure on lawmakers goes up. So they enact laws and policies to reduce frequency of DWI and also reduce number of drinkers who start DWI and increase number of people who stop DWI. These are our fourth and fifth balancing loop, and the final loop is parental influences. So as number of DWI trips increases, number of trips caught by parents goes up, parental monitoring increases, which leads to higher fraction of DWI stopping DWI and lower fraction of non-DWI drinkers becoming DWI or alcohol impaired drivers. Now I'm going to show you a couple of reinforcing loop in our model. The first two shows the impact of alcohol marketing on consumption. Higher consumption leads to higher revenue and higher marketing expenditure. The third one is about impact of alcohol advertisement on number of drinkers. As revenue increases, number of drinkers increases, revenue goes up, and that leads to higher marketing expenditure, which leads to higher number of drinkers. The fourth and fifth one are peer influences on drinking initiation through social media and consumption through social media. So the fifth one capture the fact that when number of drinkers increases, fraction exposed to alcohol related content posted by friends on social media increases, which leads to higher number of drinkers. And the fourth one is about the impact of peers on consumption. So that is the fourth one. As I mentioned, we calibrated the model using different data sources. This slide shows the result, the blue line, the simulation output, and the data for abstainers, non-DWI drinkers, alcohol impaired drivers, and total arrests per year. As I mentioned, this model is a subscripted model, so it can generate behaviors for each age group, but I'm showing the total of these stock variables. And here is the impact of the interventions. We implemented intervention at 2020 and simulated the model until 2030. The first intervention that I'm going to test is increasing probability of arrest in 2020. As we expected, it reduces total DWI trips and it reduces alcohol impaired drivers. Increasing parental monitoring reduces DWI trips and it reduces alcohol impaired drivers. And this is more interesting when we reduce frequency of DWI. Frequency of DWI is the number of times a teen drive after drinking per year. So when we reduce that, total DWI trips goes down because total DWI trips is multiplication of frequency of DWI and population who DWI. So that goes down, but population, alcohol impaired drivers goes up. The reason can be seen in the next slide in our group, in our causal loop diagram. So when we reduce average frequency of DWI, DWI trips goes down, which leads to lower arrest and lower visibility of enforcement and lower perception will get cut. So that would lead to lower fraction of DWIs stopping DWI and higher number of drinkers who start DWI. So that leads to higher number of alcohol impaired drivers. The next intervention that we checked is reducing alcohol advertisement. If we stop advertising alcohol, number of abstainers would increase, number of drinkers would decline, number of alcohol impaired drivers would decline, and total DWI trips will decrease. So the main takeaway is that we showed in this model showed that effort to reduce the frequency of DWI have benefits. It reduces number of DWI trips, but compensating feedback loops increase the population of teens who drink and drive, which is not desirable. So policymakers need to consider the complexity of interactions between different prevention mechanisms as they consider designing effective interventions. Our next step is to conduct our second GMB session in which we simulate the model, test the model with our subject matter expert and discuss intervention. We will revise the model based on their feedback. This study is part of an ongoing R01 project. My colleagues are interviewing young adults who participated in a nationally representative longitudinal study, and hopefully we will present more work in the future system dynamics conferences. Our main goal is to understand the complexities of the mechanism leading to riding while impaired and driving while impaired, and how to physically and effectively intervene to bolster the overall public health and to save lives of young drivers. Thank you very much for listening to my talk. Please contact me. I provided my email address. Thank you.